you have an activity diagram. This is like an activity diagram. And in this activity diagram, you'd like to simulate some kind of actions. And one of those actions, so, this is empty, nevertheless, who cares? So in one of those actions, you want to execute a Python code. And the problem was that if you have an external library here, so this is like an external library, and this is a Python code, so this is an opaque action executing a Python code, you cannot really do is use this external library. This is not working. You cannot do that, sadly. So what if you still want to use this external library? Can we find a solution for that problem? And we came up with a proof of concept that shows that yes, of course, you can do something with that. And the solution is the following. So what if we create a separate Python application? So this would be like a Python application. And in this Python application, you have some business logic. So it actually does the calculation or whatever you need. And this business logic, of course, could use this external library. That's no-brainer, of course. You can use it. Now, we only have one problem. It is how to connect Cameo to this Python application that is running separately. So we want to achieve this kind of connection somehow. And the solution, the way you can do that, is that you could define here an HTTP interface. So HTTP interface here. And in this action, as an opaque action, you could actually execute some kind of HTTP actions, so an HTTP GET or POST or whatever you need. And you could send some data, some information to this Python application, and then it receives it. It executes some business logic. It uses the external library, whatever it wants. It could even return some kind of response. You see some kind of response here. And this response could be used by this activity diagram for, well, whatever purposes. So here we can use this data. We can fork it and use it multiple places the way we want. So what we did is we actually created a Python application, a very simple Python application that is just returning some kind of data, but it is able to receive some kind of input, so, and it can also return some kind of output. It opens on a port, basically a socket, and we wrote some helper actions that you can use without basically any kind of programming in your activity diagram, so you can talk to this application. The advantage of this approach is that you don't even need to run this application on your local computer. So imagine this is some very expensive operation that requires, like, huge amount of CPU usage or whatever. You can run it on a server, absolutely. You can even write this code in whatever language you want. So if you are not familiar with Python, but just with whatever Java or JavaScript, or you can name it, you can use whatever language you want. You also have the advantage of here you can write some algorithm, and that's fine. But you can also kind of add this algorithm to a physical device. So imagine you have an IoT device here at this place, and which also can open a standard basically REST interface. So it's like a REST interface, which is based on HTTP. So it can open up an interface like this, and that means from the Cameo you can create a simulation. which is actually talking to a real hardware like an IoT device or anything like this. So this is what we came up with, and now I will show you how exactly we did it. First step was to implement some kind of server in, for example, Python. Lots of people like Python. I myself am a Java developer, but I really understand why people like to write code in Python. It is kind of really easy, I would say. So the whole application is basically consists of this single file, this op.py, which is using Flask, which is an external library. So this Flask, which helps you to create a very simple web server. And here we have two resources. So one is the root resource, which executes when a request reaches this resource, and this will just return this kind of string as a JSON. JSON is a kind of special format. We will see it very soon. So just to give an example how it works, I just have it up and running. So I just wrote Python and op.py, and then internal server is started to run. Basically that's it. So just like one line, and then I can open a browser and just add this, provide this address. So it is running on the local host, that means the local machine, and on the port 5000. This 5000 is actually, it's written like here. So localhost and this IP address are the same. So you just press enter. As you can see, this string is basically returned, and this is called JSON. This format is called JSON. It consists of this special bracket, this one, and it has like key and value pairs. And you can also provide like a list and stuff like that. But you can find it on the internet how to write a JSON file. It's really, really simple. It's kind of unstructured data, I would say. So basically that's it. So another thing that I created is another endpoint. So this is quite dumb. So it doesn't have any kind of input. It just returns some output, and that's it. But normally we would want to create some kind of calculation or some kind of process. So which has kind of some input and which returns some kind of output. And the way we can do that is we defined another resource. This is the root. By the root, you can define a resource, and we provided method called post. And post means you can actually send some data. And let's see how it works. So in the request, we have some kind of data, and we ask it in a form of JSON. And from this, we can get some parts out and create a new string that basically says that if I have this data structure coming in, it will have two fields. One field will be email, the other will be age. And we will create a string that says email address is whatever age years old. So this is like really, really simple. And we will return it also as a JSON. So, and the structure will be result, and the result will be this kind of result. This is probably a little bit complicated, seems like a little bit complicated, but it's really, really easy. So let's just give it a try. So in order to send this data to this endpoint, they call it endpoints or resources. They are the same, basically, just using different name for the same thing. I'm using Postman. This is a standard testing tool. It looks a little bit complicated, but normally it's really easy. So I have to define here the method, which is post. I have to define here the address. So this is the address. and I have to define body. So this is the data I want to send, and set it to here, like to JSON. And then I will provide some information. So my email address is like this, and my age is like this. And if I send this data, I expect in return something like the email address is whatever years old. So I send it in, so you can see the result is of this format, and it says result and double point and joe.chandler@gmail.com is 41 years old. So we already have a server here running, getting some data, doing some kind of transformation, returning some data. Of course, if you need to do some magic here, some kind of mathematical calculation, whatever, this is the place. Sorry, here you write your code. And the thing is that you as a systems engineer don't have to kind of write this code here. You can ask anyone from the from the developers or some third party to do it for you in whatever language you want to use. So let's check what we did in Cameo. So I have a project here, and so okay. So okay. So let's how we can do that. Let's see. Okay, so let's see how we can do that in Cameo. So in order to create this kind of simulation, I had to write some kind of um, special opaque actions. So for this, we need 3 categories. So one category is how to create a JSON file or a JSON structure actually from this model. So this is one part. And we have a second part is how to send this request to the server. So this is the second part. The third part is how to get the data, how to kind of extract the data received from the server. So this is the first part. The way you can use it in order to create a JSON structure. So in order to create this kind of structure, you need to use those 3 different uh, actions. So in the HTTP under JSON, you see there is a create JSON, add integer to JSON, add string to JSON. You can, of course, extend it by add boolean to JSON or whatever you want. So it works the following way. Create JSON creates just an empty JSON, so it doesn't have anything. It's just basically empty. And by add string to JSON, you need to specify a name. So this is like a key and a value. So key value, key value, key value, or name value, the way you want. And okay, so let's see what it does. So if I start a simulation like here, so simulation, run, and okay, I will slow it down a little bit. So as you can see here, the result is empty, and here we provide the email, we provide the value, and this result is already a JSON. And I will stop like here, and here the result was also a JSON, so it was an extended JSON. So we step by step kind of extend the JSON file. So I will probably put a breakpoint here, so we don't have to wait for it. I can speed it up a little bit, and I will restore this whole thing. So it calculates, and yes, There we are. Okay, so as you can see here, create JSON created an empty JSON file. What's string to JSON? There were 3 inputs. So the JSON input was an empty JSON. The name was the email. The value was my email address. And the new JSON is the JSON that we created from the input. So this kind of structure. And this will be this new structure, this one, will go into this next action, which will add age and the age value as well. So the result will be email, my email address, and age, and my age. So we have this structure. And why is it kind of important? And this is important because, of course, you can create all those things by hand by having an opaque action that kind of just returns this string. However, normally in a simulation, you will have all those data coming from somewhere, and you need to put it together. So it's, I think, personally, I think this is a more elegant way to work, because then you don't have to kind of code. And in modeling, my personal opinion is that whenever we can avoid to write code and do stuff by modeling, is I think it's a better way. It's my personal kind of opinion. But if we are modeling, then probably we should model. If you want to write code, then probably we should write code. And mixing those things up too much is probably, yeah, it's doable, but I don't think I think personally that it's not so much elegant. So the next step would be, okay, so we already have this kind of structure, so we need to send it to the server. So we have this HTTP post JSON. Yeah, the name is kind of not very nice, still gets the job done. What it does, it has 2 inputs. One input is a URL, which is a kind of the location where the server runs, and the other is the data. So it will basically just send a post request to this location with this data and gets the response and returns it. Because I just have a demo version of this of Cameo, I didn't. So it has some kind of limitations, and I didn't want to spend too much time on like error handling and stuff like that. So this could be definitely improved, but currently it gets the job done. So let's see. So I will put here a breakpoint, and I will let it run. So what we expect is that to this location, this data will be sent, and the response will be this one. So this is what we expect. So let's see how it works. Okay. So the response here is exactly what we expected. So result is my email address is 41 years old. But that's great. So in order to work with this data, because this is a string, we need to get out, we need to extract, actually, we need to extract the data, the result from this string. So we don't care about the structure, we just want the actual result. And to do that, I created another kind of opaque action, where yeah, this is, I hope this is, yeah, it's an opaque behavior. Sorry, this is opaque behavior. So I created another opaque behavior, which is a kind of code. You can think about a kind of code where you can specify JSON as an input and the name of the field, and it will extract the string, get the string from the JSON. So I will put here again a breakpoint, and let's see. So the incoming is this whole JSON structure, and hopefully the returning value will be like joe.shandor@gmail.com is 41 years old. So let's see. And that's it. As you can see, the data is extracted from the response. And then from here, you can work with this information, work with this data. So that's for the simulation. If you are interested, I will go a little bit into the code, into the actual code, how I implemented this kind of functionality. So the first thing is how to create a JSON. What actually a JSON is? So JSON is a value type which extends basically generalized basically string. So JSON is a string, and I had this concept for this JSON because I think it's more elegant to have certain types, working with certain types, not just some generic types, but some specific types, because here we are thinking about JSON structure, even if it's a kind of, we are simulating it via just a string, because also JSON is basically just a string, but with some kind of internal structure. So create JSON is very simple. It's written in JavaScript, and it creates an empty structure and returns it as a string. So it says create a very simple structure, and JSON.stringify is creating a string from this kind of structure. So this is how it will be empty. And let's see, just add string to JSON. The other is exactly the same. It's also written in JavaScript. So we have an input JSON and the name and a value. So what we do first is we parse this string to have this kind of structure. We have its structure. Then with the brackets, we can say that, okay, in this structure, set this name to this value. And then we will return this whole structure as a string. This is like create a JSON, add this add or update this field, and return the JSON, this new structure as a string. The same is true for this one. Now for HTTP post, so at first I created just an HTTP GET, and then I improved over that. So let's probably start with the HTTP GET. It will be easier to understand and to see the difference. So it is written also in JavaScript. So the trick was the following. Java has a class called URL, which is basically just a kind of address. But it has a special method called open connection. This is very interesting because it's actually opening a connection. It's creating a request and response. So by open connection, the connection is opened. It has some kind of response code, which will be probably 200. We are not handling the error. So I just have here this code, but this is basically that code. We are not handling the error, but we could. So later, I think this code can be improved. So what we do here is get, here we want to basically get the response, so get the data that is returned by this server, and return it as a string. So this is what we want to do. And how we can do that? We can do it the following way. We have a connection and we get an input stream of this connection. So this is basically the incoming stream of data. And we can kind of envelope it into an input stream reader, which we can envelope it into a buffered reader, and we'll create a string builder. The string builder is a class which, when you create an instance from the string builder, you can add new lines to this structure. So a new line, add new line, add new line with this append method. And at the end, we can say that, okay, please return it as a string. So what we do here, we go line by line and just add it to this kind of list, basically. and we close the connection, and we return this string builder as a string. So again, it's like really easy. We have a URL, we open a connection, we get the input data and transform it to a string. So this is basically Java code. This is a whole Java code, but it's running in a JavaScript Rhino, which is a JavaScript engine over Java. So all those classes are Java classes, and if you are really interested in how they work, just Google for it. Those are basic built-in Java classes. So that's it. So this is how we can get some data. Now for HTTP post, it's a little bit different because we also need to send the data. So the second part of the code, this is the same. So this is exactly the same that we saw before. One minor hack is here to use UTF-8 for the response. I added it later and I forgot to add it for the HTTP GET, but okay, it doesn't really matter. I mean, right now. So the thing is, the difference is this first part, which says that, okay, after we open the connection, we set that it has an output as well as an input. We also set the content type to application JSON, and we also say that, okay, we'll accept application JSON, and we set also the request method to post. That will mean that we want to send some data, also receive some data in the format of a JSON file, and we will use the post method. So the post, get, put, delete, patch, and so on are part of the HTTP, I would say, reference. So if you're interested in what they are, you can again Google for HTTP post or whatever, and it's written all on the internet, so you can read about this on the internet. So the first thing is we need to send the data, and in order to do that, we will get the output stream of the connection. So we have the connection, and this will be the output. And we can just say that, okay, we have the output stream. We can envelope it by this output stream writer. And for this output stream writer, it has a method called write for a string. So it will write all the string into this stream, which will be then transferred to the other side, so to the server. And it requires a flash operation indicating that, okay, all the data is written. So please, right now, you can send it out and wait for the response. And so then we wait for the response, get this input stream, and we will read all the input that we will receive, and then we will return it. So basically that's it. The whole thing, the whole trick is that you don't need to understand this. You don't absolutely need to understand this. You can just simply grab this item and drag and drop here and just connect the ports and use it. So basically that's it. So if you are interested in the model and also the Python code, they will be all available on the internet, and you can download it and you can play with it. If you have any kind of questions, please feel free to contact me either on this email address or on Discord or via LinkedIn. And I'm really happy to have you answer your questions, or we can work together to improve this library for the greater good. Okay, so thank you very much for your attention and have a nice day.